What is curvilinear coordinate and how you define displacement in curvilinear coordinate? Curvilinear coordinates are a coordinate system for Euclidean space in which the coordinate lines may be curved. In Cartesian coordinate, you have straight lines, the x, y, z, these are straight lines. But in curvilinear coordinates, the lines may be curved. That means this is a curvilinear coordinate q1, q2, q3. In Cartesian coordinate, we represent the coordinate as x, y, z. But in curvilinear coordinate, we generally represent the coordinates like q1, q2, q3. Examples of curvilinear coordinates are cylindrical coordinates, spherical coordinates, etc. Curvilinear coordinates may be derived from Cartesian coordinates and vice versa. That means we can represent the curvilinear coordinates q1, q2, q3 as functions of x. That means x is a function of q1, q2, q3. Y is also a function of q1, q2, q3. Z is a function of q1, q2, q3. And you also define the curvilinear coordinates q1, q2, q3 in terms of x, y, z. How you define displacement, suppose dr in curvilinear coordinate. In Cartesian coordinate, dx may be defined by the partial derivative of x with respect to q1, then partial derivative of x with respect to q2, and partial derivative of x with respect to q3. q1, q2, q3 are the curvilinear coordinates. So what will be dx square? Dx square will be equal to partial derivative of x with respect to q1 and partial derivative of x with respect to q2. Similarly, if you have more curvilinear coordinates, we can represent in general partial derivative, that means we can represent it qi and qj. And when you multiply dx with dx, then you have factors like the partial derivative of x with respect to qy and partial derivative of x with respect to qj. And you have two terms, derivative of qy and qj. Similarly, for the y coordinate, you can represent the displacement dy square is equal to partial derivative of y with respect to qy and partial derivative of y with respect to qj, then dqy dqj. Similarly, for the z coordinate also, that means dz square also equal to this. And in curvilinear coordinate, the differential displacement is due to the changes of dqi. And what will be dr square? Dr square will be equal to dx square plus dy square plus dz square. So if you take common in these three, if you take dqy, dqj common from these three, then you will get, here I have taken dqy, dqj common. So you have partial derivative of x with respect to qy, then partial derivative of x with respect to qj. Similarly for y and similarly for z. And this term in the bracket we define by gij. So the next term equation will be dr square is equal to summed over ij gij dqy dqj. Suppose this is equation number 1. And here we define a factor gij, that is equal to partial derivative of x with respect to qy, then partial derivative of x with respect to qj, this term, then for y, and then for z, this term we define it as qij. And suppose this is equation number 2. And for orthogonal coordinate system, this factor, this is equal to 0, that is gqij will be equal to 0 when I is not equal to j. That means we take I equal to j. So if I equal to j, they are orthogonal. They are called orthogonal coordinate system. So from equation 1 you see you have a factor when I equal to j, you define g I j, that will be equal to h1. Here you define g I j as h1, and when I equal to j, this factor will be equal to dq1 square. Similarly, you have for h2, you have h2 dq2 square, and for h3 you have h3 dq3 square. So for orthogonal curvilinear coordinates, equation 1 becomes dr square will be equal to h1 dq1 square plus h2 dq2 square plus h3 dq3 square. And in equation 2 you have gij is equal to this much. So gij will be, when I equal to j, this will be equal to hi square. So equation 2 becomes hi square is equal to partial derivative of x with respect to qi square, then for y, partial derivative of y with respect to qi square, partial derivative of z with respect to qi square. Suppose this is equation number 4. So in general you can write from equation 3, dri, you can write represent equation. You see, you can represent equation 3, dri is equal to hi dqi. Okay, that means for 1 you write h1 dq1, for 2 you write h2 dq2, like this. So this is the general equation. And if you write the derivative, the differential of r with respect to qi, then that will be equal to hi into ei, um, ei cap. That means this will be the unit vector. If you define the displacement vector like this, partial derivative of r with respect to qi, then this can be written as hi into ei cap. And here ei cap is the unit vector in the qi direction in the curvilinear coordinate. So how you define the displacement vector in curvilinear coordinate? The displacement vector can be defined as h1 dq1 u1 cap plus h2 dq2 e2 cap plus h3 dq3 e3 cap. And here hi, that is h1 or h2 or h3, they are position dependent. Similarly, hi dqi, this is dimension of length, and when dimension of length is multiplied by the unit vector, that will be the displacement vector. So this is the expression for the differential displacement dr in curvilinear coordinate. This will be the expression for the differential displacement dr, and you have to remember this equation so that you can find out the uh, divergence, gradient, curl in case of curvilinear coordinate. Thank you.